Hello, and welcome to this short training on effective ventilation strategies for multifamily buildings. This presentation is brought to you by the Oregon Housing and Community Services Multifamily Energy Program. This module, discussing standards and guides, is the second module of 3 in this series. In this presentation, we'll cover the variety of standards and guides available to building designers, HVAC contractors, and energy consultants to size, scope, specify, and design appropriately engineered ventilation systems that either meet code minimums or go a step beyond for optimal health, energy use, and comfort in your buildings. We'll discuss the Oregon Code, ASHRAE ventilation standards, which underlay the Oregon Code, and design resources from the Building Science Corporation. And then we'll look at comparisons across and between these standards and how they apply. First, buildings in Oregon must meet the ventilation requirements described in the 2014 Oregon Mechanical Specialty Code. The code establishes the baseline ventilation requirements for new and existing multifamily buildings and stipulates what is needed to confirm code compliance. The Oregon Mechanical Code is based on the International Mechanical Code. ASHRAE, the American Society of Heating, Refrigerating, and Air Conditioning Engineers, is the preeminent body for setting ventilation standards. ASHRAE has 3 different ventilation standards that apply to multifamily buildings. Each provides the minimum requirements for ventilation systems and the building envelope to provide acceptable indoor air quality in residential buildings. ASHRAE 62.2 applies to multifamily dwelling units and can be used for either low-rise or high-rise buildings. ASHRAE 62.1 applies to low-rise multifamily corridors and common areas. ASHRAE 90.1 applies to high-rise buildings generally, including high-rise multifamily residential buildings. For the Oregon Multifamily Energy Program, both our whole building and bundled savings packages reference ASHRAE for ventilation standards. The Building Science Corporation is a private consulting company that also happens to be one of the most respected voices in building science. As part of their work, the Building Science Corporation conducts research and produces guides and trainings across multiple aspects of building science. They are the go-to expert resource among industry professionals. Their ventilation guide, GM 1501, provides mechanical ventilation requirements of occupied spaces in new low-rise residential buildings. The International Code Council's Mechanical Code is another resource for specifying ventilation. Its ventilation chapter can be used as a baseline standard for ventilation in new and existing multifamily buildings, and includes information on how to confirm code compliance in regulatory and non-regulatory settings. So let's see how each of these guides get applied to a building design in practice. First, each guide has a formula to calculate the requisite ventilation rate for dwelling units. While the formulas shown on the screen vary slightly, the end result is a system between approximately 45 cubic feet per minute and 100 cubic feet per minute for most typical apartments. Next, each guide dictates how the ventilation may be met. Each requires some form of mechanical ventilation, either exhaust, supply, or balanced, though the ICC and Oregon Code allow for natural ventilation in more leaky buildings. For a full description of these ventilation system types, we encourage you to watch the first module in this series. Finally, each guide describes the controls and operations requirements, the key being that ventilation is controlled to run continuously whenever the space is occupied. Next up, airflow testing. ASHRAE stipulates that all devices serving individual units shall be tested, and it includes a detailed testing protocol using equipment such as a flow hood or flow grid. These standards also suggest filtration levels. ASHRAE requires MERV 6 or better, while Building Science Corporation recommends MERV 9 or better. Finally, these standards also mention the relationship to adjacent spaces and basically recommend a blanket expectation to minimize air movement across envelope components. This is the compartmentalization concept we discussed in Module 1 of this series. Use gasketed doors and air seal the wall assemblies between apartments. Another factor is to ensure that your intake air is coming from a non-compromised source, 10 feet away from contaminant sources, 3 feet below any exhaust vents, and that the openings are unobstructed, yet protected by screens. Additionally, the guides discuss the additional need of spot exhaust ventilation from kitchens and bathrooms, and requirements for spot ventilation flow rates, controls, and dampers. Thank you. This has been the second of 3 modules on effective ventilation strategies for multifamily buildings. We hope you've enjoyed this presentation and hope you'll continue on to watch the final module, in which we'll discuss the business cases to prioritize one system method over the others. Thank you for watching.